Hello, everyone. Thanks for joining us today. Really appreciate all of you attending all these webinars. Makes it very worthwhile from our point of view. Um, we've got a really interesting topic today, which is the topic of generating CI data sets, kind of the how and why of how you might do it and why you might do it, how you've done it historically, and then we're going to talk in particular about a new DBT command that has made our lives much easier for doing this stuff. And I'm going to kind of talk about some of the pain. I'm going to talk about how you might have historically done it. And I'm going to hand over to Chitij, and he's going to talk about how they've built this new feature, what it does, and talk a little bit about kind of how they've been thinking about this on the DBT side. Before we jump in properly, for those of you who are joining us for the first time, we run these webinars every 2 weeks. They are typically on kind of Looker and analytics engineering focused topics. They aren't typically selling any tool. They're not about selling spectacles, really just to get the Looker community together and discuss interesting topics. In 2 weeks' time, we'll be doing a guide on the Looker marketplace. So we'll be talking about what it is, what you can what and how you can install things from it, and highlight some of our favorite kind of applications, content blocks, actions, visualizations, all that type of stuff from the Looker marketplace. So if you're running Looker in your org and you want to extend it in certain ways and maybe haven't explored the Looker marketplace fully, highly recommend joining that. You can sign up for it at spectacles.dev/webinars. You can also see all of our historic webinars there as well. I will introduce myself properly here, and then I'll let Chitij do it for himself, because I'm sure he'll do a much better job of giving his history than I will. But my name's Dylan Baker, Atlas Baker now. Clearly, I took this from a slightly old slide. But I'm one of the co-founders here at Spectacles. I've been a Looker user for a very long time. I was fortunate in the context of DBT to be DBT Cloud user, something like 25 or 27. So I was fortunate to be a very early user of DBT Cloud as well. And so excited to be talking about both today. Yeah, two tools that are very close to my heart. Before we jump in properly, a couple people have been, oh, sorry, that keeps happening when I click on the chat. A couple people have been talking about the Slack channel that we've mentioned. We run all of our Q&A through a Slack community. So if you aren't a member there and you want to join, I've just dropped both of those in the chat. Join there. Let us know where you're calling from. We always fun to see kind of where people are joining us from. And I will get started. Let me just share my screen again. Perfect. So this is going to be split in two. We're going to be kind of splitting the time of this webinar. I'm going to start with a bit of a history about kind of how CI works, slim CI, why that's sometimes a problem, and how it's been done historically, kind of paint the world up until a release of DBT a couple weeks ago, and then going to hand over. We'll see a live demo of the new functionality, talk about different use cases where it might be useful and things like that. If at any point you have questions that you'd like us to answer at the end, just drop them in the Slack channel, and we'll have a full Q&A then. So I expect this is not brand new to most of you, but CI may be a new concept to some. CI, continuous integration, and in this graphic, continuous deployment, is the idea of automatically testing in a variety of different ways code, different commits. And so you can see in this graphic, this is from the team at GitLab, and I like it a lot, and I think it does a good job of conveying this, is you kind of get a new commit to some piece of code in, and then it runs some form of testing on it. And so for different pieces of software, that'll be different things. For like Python code, it might be unit tests and integration tests. But for something like DBT, it will be something like a DBT build, where it's going to build all of the tables in a CI environment. It's going to test, run your tests on either staging data or prod data, however you've got it set up, and let you know so that either you can deploy it right away or upon review from someone that all the code is working. It is doing what you expect. It conforms to your organizational standards for whatever type of code you're writing is. and allows you to catch bugs automatically, make sure there's no regressions. And so for those who are familiar with spectacles, we do this for Looker. For those who use DBT, DBT build, DBT, historically DBT test were commands that allowed you to do this. You might also be running things like SQL Fluff to lint your SQL, a whole range of things depending on what language you're using. And so when you get started with DBT CI, typically you'll start with DBT build. You'll just do a full DBT build that will run all of your models and test all of your models. And often when you're getting started, because you don't have a ton of models, and you may be on, a relatively smaller data sets, though that's obviously not going to be true for all organizations, the easiest place to start is just to run DBT build on every commit, or every commit that's on a pull request. You might do this in your own CI tool like GitHub Actions or Circle CI. What I've got a screenshot of here is what this would look like in DBT Cloud. And so in DBT Cloud, you can set up jobs to run on CI super, super easily. It's really just a couple clicks of a button. And so if you are an org that isn't doing this today, it can provide a ton of value, and would recommend kind of definitely having a look at it. And the way it works, as you can kind of see from some of the logs here, is that it generates, runs your command, but into a staging data set. So for each pull request, it generates a schema called something like DBT Cloud PR, and then a series of numbers. The numbers are actually the job ID and then the pull request ID, pull request number. But this will generate a full data set in CI that has built all your tables or views, whatever they are, has built all your models and has tested them all, and you'll get a sense of whether the code change that you have made is positive or negative. And so typically for most people, we recommend starting with this. But in time, you're going to find that this might become a kind of lengthy and cumbersome experience. You may find that a full DBT build may start taking upwards of 5 minutes, 10 minutes, 20 minutes. It really depends on obviously how many models you have and how much data you have and how you're materializing things and things like that. And in CI, ideally, you want these things to run as fast as possible. You don't want to get in the way of the developer experience. You don't want to get in the way of people committing code, wanting to merge it quickly, and then having to wait 45 minutes before they can do so. That's obviously ideally not what you do. But if you just do DBT build with nothing else, you might eventually get that, because it's building every model in your project every time, and that can ultimately be a little cumbersome. And so many of you may have heard the term Slim CI before. That is typically the next step of this migration along DBT CI. And the idea is, if I have just affected, let's say, dim customers, this model over here, why should I have to build everything else? Why would I not just build dim customers and things that are downstream of dim customers? And so you'll see here that would be dim customers and customer orders. And in this case, instead of running, 7 models, we would just be running 2. And that would hopefully take, roughly 2/7 of the time. And you can significantly reduce the runtime of your DBT CI runs. DBT makes this super easy out of the box. So you can, with a combination of the state selector and the defer flag, run a command like this that basically says, run everything downstream of what has been modified. So this select state modified plus is saying run all models that are either the models that have been modified or the ones that are downstream of those that may be impacted by the change, and defer to my production state. And so the defer flag does, it says, if a model that precedes this one doesn't exist, go and pull it from production so that it has data to pull from. And so if you imagine going back a slide, dim customers, if we start everything here, these 2 staging ETL tool models won't exist in that schema, in that environment. They need to be pulled from somewhere, and that defer flag helps you do so. In DBT Cloud, this is all you need. It handles the state between your production runs and your CI runs to figure out what has been changed. If you're running this DBT core, you're going to need a few other flags, and we'll cover those in the demo a little later, but there's things that point to your manifest files and things like that. And so what this allows you to do is kind of get down to a slim CI. You're really running as few models as you need to be basically 100% confident that everything in DBT works. Now, that's great, but occasionally it can be a problem, and it's mostly a problem if you need downstream services to consume from your CI environment. So there's many ways of testing downstream processes, and many of them require full data sets. Spectacles is an example of this. So Spectacles will tell you on your DBT change whether you are going to break anything in Looker. DBT doesn't tell you that in isolation. It just tells you whether DBT is working functionally. But with Spectacles, you can say, hey, does this DBT change break any of my explorers? Does it break any dashboards? Does it break any metrics? But to do so, Spectacles runs a query against every explorer in your Looker instance. And to test every explorer in your Looker instance, all the tables and views need to exist in the CI dataset. And so if you're doing a slim CI, there's a bunch of tables and views that won't exist that Looker will need, or any downstream process that might be using the CI dataset will need in order to test things. And so you end up in this place where you have this kind of balance between wanting to do a slim CI run and wanting things to run as quickly as they can there, but also wanting to generate a full data set, which was the kind of original output of your full DBT build, without slim CI, without state modified or anything like that. And so historically, up until, let's say, the world a month ago, not even, there were a handful of things you could do here. The first is that you could run everything with a limit 0. So you could put a macro in either your staging models in DBT or all your models in DBT and do a full DBT build, but not have any data go through it. And the downsides here are obviously that none of the data is going to exist in the tables, which makes DBT testing basically invalid because all of those tests basically require the data to exist. And so it works if you just need a schema to test a downstream process, but it doesn't work if you really want to test everything in DBT. And so it's a way of generating the schemas, but generally gets you there quickly, but with a meaningful issue, which is that the data is not going to be there. Which brings us to kind of two other options, which is what we've seen lots of people do historically. So the first is that for every table or every model in your DBT project, you first create a view to your production models. So you find the graph in DBT, and for every model that exists, you basically do a select star from the production version of this model. And that creates basically a production-like environment in your CI schema. And then after that, you do the slim CI such that it'll rebuild the models that have been impacted by your change. And so you could write a macro to do this, would be typically the way people would do this, is they write a macro, it would take the graph variable in Jinja and DBT, you'd iterate over it, and you would create, select star from production version of this model. And that can be really good, actually works really effectively. Though I'll talk about some of the issues about it in just a second, but that's kind of, I think full option one. And the second is that you can clone your production data sets. If your database has a kind of version of cloning, which most do today, you could do a full clone of your production database, your production schemas, and then run slim CI after it. And so one is kind of fully replicating all the data over from prod. One is just kind of creating pointers in the views to prod, but ultimately you're pulling your prod data into your CI data set before you run slim CI. And typically this will be faster than doing a full DBT build. Not all the time, but typically, and that's what I'm going to talk about next. So we kind of get to the question of like, what method should I use? And what method you should use is basically a factor of what warehouse are you on? And this should really read what method should I historically use? Because the spoiler to all of this is that there's now a new command that should be what everyone uses, or at least kind of 90% of the time. But historically, what method you used was based on your database and what you were using to run DBT, basically whether that was DBT Cloud or you were running DBT Core somewhere else. Before I go into depth for each warehouse, I just want to talk quickly about dbt cloud and parallelization, because it's kind of going to be the recurring theme for a few of the next slides. So to do these cloning operations or to do these pass-through views, historically, the way you have needed to do that in dbt is with a run operation command. So you basically write a macro in dbt that says, run these operations, do these things, clone these tables, create these pass-through views, whatever it might be. And you needed to put that in a macro and do that with a run operation command. And that could be really powerful. The kind of two downsides was that Jinja, really, I mean, it's a kind of dbt limitation mostly via Jinja, doesn't enable those operations to be multi-threaded or be run in parallel. So if you imagine that you're creating these pass-through views or these clones, you're doing them sequentially. And that on certain things can be kind of hamstrung. You're not able to use the full, run things in parallel, run them with multiple threads in the way that you can with a dbt build command. And then separately, and this is a very reasonable limitation of dbt cloud, is that it doesn't give you the ability to run operations in parallel either. And so you end up in a situation where you're managing these macros, and you're managing them whether you're using dbt cloud or core, but you're managing the macros, and they're somewhat hamstrung in the speed that they can be run. And I mentioned this just because it's relevant for this next section. So if you're on Snowflake, regardless whether you're using dbt cloud or dbt core, you can do the limit 0. That's going to work just as effectively on either one, but you're going to end up with empty data sets. Historically, you could create path-through views and clone on both, but because of this parallelization issue, where you're having to build one thing at a time, that was always going to be slightly slower on dbt cloud. Lots of people still do it. It still historically was going to be reasonably performant, but it was slower than what it might be if you're not using dbt cloud. That's the exact same on BigQuery. Historically, you could do all of this with the same limitations. There was just a speed component that meant that you were managing these macros and that they wouldn't necessarily run as fast as you might want them to. Redshift was similar, except it has no concept of cloning. So all you could do on Redshift was create pass-through views. I don't have a slide about Databricks because I'm just not sufficiently familiar with it personally. But as I understand it, the limitations would be very, very similar. And this brings me to basically the end of my section, which is what you can do about this now is that there's this brand new command called dbt clone that tackles most of the problems that I've just outlined. So many of you may be familiar with the problems that I've been talking about over the last kind of 10 slides or so. You may have tried to do versions of these, may have fully implemented them, started and decided it was too complicated. And it's why it was so exciting for us when the dbt team released dbt clone in the 1.15 release. 1.16 release.
1.6.
6. There you go. I knew there was a 1 and a 6 in there. Thank you. And what dbt clone does, and I'll do a kind of quick highlight of it now before I hand over, is it basically combines the best of versions 2 and 3. So if you're on a warehouse that needs pass-through views, it creates pass-through views. If you're on a warehouse that supports cloning, it will do cloning. But most importantly, from my point of view, it runs it all in parallel, or like to a degree, and we'll talk about that in a second. But it parallelizes this much more than you could historically. And it means that you don't need to manage a macro for it. So you can kind of just hand off all of this to dbt, to this new command, and generate very quickly full CI data sets before you run a Slim CI. And it's been kind of transformative for us at Spectacles, because anyone who's using the dbt Spectacles integration has needed to go through this kind of work that I've talked about in the prior slides. And dbt clone has taken over a lot of that. And it, as I said, it really just combines the best of both worlds of 2 and 3 here as necessary. You don't need to internalize exactly how cloning works on your warehouse and what's going to be best where and how to do it all and manage the macros for it. You can really just, it's all been abstracted into a command that gives you a ton of power to really build, I think, very fast CI pipelines that can do quite complex things with these. So on that note, I'm going to hand over, and we're going to see this new command in action.
Cool. Before I get into that, I wanted to introduce myself briefly. So I'm Kshitij. I'm a senior software engineer on the dbt core team at dbt Labs, and I've been at dbt Labs for about 8 or 9 months now. And clone is like one of the first like big commands I've shipped end to end. So I'm like really excited to show it to you. Before I get into a demo, because everyone loves those, I think I'll add one note to Dylan's great presentation from previously. Databricks actually does support zero copy cloning. So that is natively supported. And if you're on Postgres, it does not. So Postgres, Redshift don't, Snowflake, BigQuery, and Databricks do, if that helps. Cool. So I'll get into it. Let me share my screen here. So I'm in the Jaffle Shop project, and just to kind of show you, can everyone see my screen? Okay, is that working? Yes, no.
Yeah, we can see that. Look, all looks good.
Okay, cool. Yeah, so just to show you that I haven't done anything yet. So this is my source schema here in Snowflake. And if you're confused, like if you want to know what this interface is, this is NoSQL, which is the Snowflake CLI command, just like a different way of querying Snowflake. It's the exact same thing as if you were to do it in the web UI, but just for the sake of this demo, it's a bit easier to show everything at the command line. So I haven't done anything here. So I think the first thing I want to do is in my Jaffle shop, I just want to run it. And essentially, I might have to do seed first. There we go. Now run should work. Yep. Okay. Cool. So now I have stuff in my source, right? So you can kind of see I've only shown the tables here, but if you were to look at the views, you'd have the staging views. So now what I want to do is I want to go over here. This is in my clone schema, and essentially you can kind of see that there's nothing here, right? In my clone schema, which is just and so what I want to do now is at the very bottom here, and let me just move this up slightly so that you can see it. So the command here is dbt clone state target. This is where clone will write its output artifacts. Target snow clone. So essentially, if I do dbt profiles here, I have two different profiles. I have a Snowflake one and I have a snow clone one. And the difference really here is just the schema. So notice that this one has underscore clone at the end. So I'm saying like I want to use the snow clone schema just so that I clone to a different target, to a different schema in Snowflake. So state one is the input one, and then the target path is essentially the output for dbt clone. So now what I can do is I can just run this. And it'll run. And once it's completed successfully, now if I go back into the clone, it'll show that there's 5 different tables in here now. Notice that the seeds also got copied over by clone. It basically just copies over every object that it can find. So that's it. That's like a very, very quick demo. And then I think one thing I forgot to include here is that if you go to like information schema that I left out of this demo because it takes a while, is that if you go to information schema, you can actually see in Snowflake that this operation actually cost you 0 bytes. And so in Snowflake at least, this operation was completely free. Cool. So with that out of the way, I'll continue on here. So I guess like the question comes really like, where would you use this, right? And I think the way I think about it is that uh, clone is really kind of the CD part of the equation, where slim CI is more of the CI part, right? So clone is basically what you use it where you want a full copy of an environment in a different environment, whereas like slim CI you use when you want to rebuild only part of the environment uh, in a certain environment and kind of say like use prod or use whatever environment you want to defer to for the rest. Here is like, no, I want everything. I want my own local sandbox, and I want to make changes in that sandbox, but without it costing me an arm and a leg to keep kind of two copies, right? And I think one place where that illustrates this pretty well is blue-green deploy. So I took this slide from a presentation by Montreal Analytics, where essentially what you want to do is you want to have one prod, which where the data is essentially always tested and all the tests always pass. And so one of the problems that happens in DBT sometimes is that when you do a full run and then you do a test, sometimes the test might fail in your prod environment because like some bad row or something came in, right? And so what you want to do is you want to trade off between accuracy and timeliness in the direction of accuracy. And you want to guarantee that whatever is in prod is always like tested, even if it is slightly stale. And then you can have your data team kind of get paged like, hey, this run didn't work. And then you can kind of go investigate it. But the data is always reliable up to a certain point. And so the mechanism you use for this is blue-green deploys, where you essentially keep two copies of your data. Think of it kind of almost as like active-active replication. At any point, you should be able to switch between the two. So what you do is in one, like here, you can kind of see green is filling up, it tests it, and then it swaps. And so basically, prod is now green, and then similarly, now it's blue, and then they're going to swap again. And so what clone is really good at is this last step, this third step, which is the run operation swap databases, because the way it's presented in the slide, you do need to keep two copies up, which means you're paying double the cost, double the compute, double the storage every time, right? Whereas with clone, you essentially only need to pay that once. And so like I'll go to the next slide, which is why even do it, right? Why does copy cloning matter? This is again stolen from Snowflake. So this one is a slide that they have about like why you would use it. So the one thing is like it's very fast because essentially no physical data gets moved, only metadata gets moved. It's you're just updating a pointer, so it's very fast. And with DBT now, because you can do all these operations in parallel, like Dylan mentioned, it means you're really not bottlenecked by the speed of IO or network anymore. Another one is cost savings. You only pay for the data once. And then if you were to like update the clone, you would essentially, at least in Snowflake, you would only pay for the diff between what was previously there and what you've added in, which is also pretty cool. So I think the last one is data in test in single command or automatically. This slide predates DBT clone, but that's what DBT clone helps you do. And then you can promote any test or integration or any test to integration prod in seconds. Also what DBT does, DBT clone does. So that's kind of like the overview of what it is, a quick demo, and why I'd use it. But as with all things, there's a catch, right? So the first big catch is that zero copy cloning is only available, native zero copy cloning is only available in some warehouses. And as I mentioned earlier, that is BigQuery, Snowflake, Databricks, not available in Redshift and Postgres. And so what happens in those databases is essentially data warehouses is essentially I think it goes to Dylan's point number 2, which is DBT creates these pointer views to all of the models in there. So that's kind of one catch. So you hopefully most of you are on one warehouse that supports this feature, so you can make use of it. The second one, which we have a ticket open for, number 7914, if you're curious, is that it's bounded by the shape of your DAG. So it's not bounded by the number of threads you can have. So let's say that essentially you have a choke point in the middle of your DBT DAG that most models are passing through. Right now, DBT clone will only like run, will be bottlenecked at that choke point, whereas it doesn't need to be because the shape of the DAG isn't important, but we have an issue for it. We'll fix it soon. This one is another one, as I pointed out earlier, the source and target artifact directories must be different. This is only for DBT core, by the way. If for DBT cloud, this does not exist. And then the last one is that clone isn't aware of the warehouse structure. So if you have a view that points to a table in your source, when you clone it, you'll essentially get a view that points to a view that points to a table. And so it isn't smart enough to basically point directly to the new table underlying. So I think that's about it. If you feel strongly about any of these or anything else, feel free to let me know. I'll be here in the Slack channel, but also like afterwards, you can find me in DBT Slack. So that was it. I think, yeah, thank you. I'm happy to take any questions.
Awesome. Thank you very, very much for that. We've got some questions coming in, so I will let people type them, but there's one already there. So question from Spencer says, does DBT clone automatically set data retention time of days to 0 in Snowflake? Which I think is a parameter on the table.
It does not automatically do it. Should it? I'm open to have that conversation. I hadn't thought of this. I guess why would this be useful? What's the context here?
I can see Spencer's typing in the
Yeah.
Slack. We've got another couple questions coming through. Let me just wait for those to come through. Spencer says time travel costs ballooned when we did our own clone. Setting that to 0 eliminates that cost. So I think the idea is that like if you're doing this clone at scale, having the ability to time travel is like multiplied, I think, probably by the number of assets that you're duplicating. Even though the storage is free, I think the delta on the time travel may be charged there.
Okay, got it. Yeah. It's not by default. I think you could probably set this at the schema level. And so that would probably be one way to get around it, is you set this thing, this config at the schema level. But I'll I can like create a ticket so that we can kind of track this. Thank you.
We've got kind of two questions related to, I think, the fourth point that you had on that last slide. So the first one says, with regards to your fourth point on DBT Cloud around warehouse structure and how it doesn't take that into consideration, and with materialized views now being a thing in certain warehouses, does DBT Clone react any differently with materialized views versus regular old views, kind of vanilla views?
I have no idea. You tell me. I haven't used the two together, but yeah, if you run into issues, ping me directly. where I think both of these features are like pretty new in DBT. And so I'd say there's a 50-50 shot it works. If it doesn't, let me know.
Can you cover quickly what when I think when a table's being cloned, that's it's obvious what's happening there. But when a view's being cloned, there's like lots of different things that you could consider to be a clone of that view. Can you talk about what
Yeah.
happens when you get to a view as part of the DAG when you're doing a clone?
Yeah. So what happens essentially is let's just say in your source, I guess I went a bit too quickly over it, so that's fine. I'll redo this explanation. So let's say you have a table, like a source table, and then you have a source view that points to that source table. When you do a DBT clone on the source view, what happens is that it creates a target view that points to source view that points to source table. And so it is essentially a view that points to a view that points to a table because it isn't aware of the structure within the warehouse. Hopefully that's a little bit clearer what's happening. So it doesn't so essentially you have two views instead of intelligently having just one. So so I guess you will always have two views, but the problem is more that the length of the chain there should be two and not three. So right now it's three. You would expect it to be two. So that's like a caveat to be aware of.
I guess worth being aware that if you change what you think of as the preceding table in your CI schema or in your clone schema,
Mhm.
that view is actually going to be unaffected because it's not directly pointing at it, it's
Yeah,
pointing
yeah,
at the data in production.
yep, yeah, that's right.
We've got a question from Jake here that says, does DBT clone use generate database name, generate schema name, generate alias name to set uh, the FQN, which
The
is not a
the fully
not an
qualified name.
anagram. Oh, thank you.
Yeah,
On a given table when it's being closed. Oh yeah, there we go. Okay, thanks, Jake. But yeah, does it use that to like uh set it up when it's being cloned? They make heavy use of that in dev CI and need clones to be like based in the right place, uh
yeah, yeah,
given
yeah,
like a
yeah,
given profile.
yeah, yeah, yeah. So if you actually look at the like the manifest of the target, so the one that clone creates, all of those things are in there, and it's using those schemas that you pointed to, generate database name, generate schema name, generate alias name. So it does use those under the hood. It I like our goal really with clone is that you shouldn't really be able to tell whether uh, a given view or table was generated via clone or if it was generated via like a regular DBT run. And I think for the most part that's true, except like the uh, view thing I talked a bit about earlier. So yeah,
Cool. I can see we got one person typing, so I'll here we go. Let's take this as the last question because I think we're at time. Is there a way I can dry run a clone so that I can look at the manifest it generates without actually running anything on the warehouse?
very good question. Not yet. No.
Awesome. Perfect. Well, I think we'll call it there. Chitich, thank you very much for this. This has been super, super useful. Thank you for both the feature itself, which you've obviously worked on and built, but appreciate you jumping on and helping us talk to everyone about it. I know our customers at Spectacles have already benefited from this functionality, and so we're excited
That's awesome.
see the
Yeah.
work that's coming up, and yeah, no, really appreciate it.
All right, great. Thank you so much. And if you have questions, I'll be in the Spectacles channel for a little bit longer. And otherwise, DBT Slack is where you can find me. All right, thanks all.
Thanks. And thanks everyone for attending. Again, the questions have been awesome. Really appreciate it. And if you've enjoyed
Yeah,
it, we've got another
excellent
one
questions.
in 2 weeks, and so we'll see you there. Thanks, everyone.
Thanks.